Yeah, so I know that Irene scheduled a meeting, so I'll start with Irene, and then we'll go on with Araceli and Neil. Okay?
Mhm. Thank you. Can I share my screen?
Yes, I opened
Okay, thank
the
you.
possibility.
Okay, so
Mhm.
first off, I have a question about the normalization in question 1, project 3. So this is from the Discord answer you said. So you basically, sorry, I need to, okay. You divide by the length of the vector and then you multiply. The way I did it was I took the cosine of the preferred direction and the sine of the preferred direction, and then I multiplied the firing rate divided by the baseline by the cosine and the sine. That's how
Mm.
I did it, and I think it's kind of the same thing. Just wanted to make sure if it's the same.
You can check by looking if the size of the preferred direction vector is 1. And if you want to be
Okay.
on the safe side, you can also add, I think, NP norm or something, or divide by NP norm.
Okay. Okay. Thank
There's
you.
something like this. I don't fully remember the syntax, but it's something like NP norm.
Okay. Thank you. And then the second thing was basically my plots for the population vector look the same for both the 4 neurons and the 8 neurons. So it's always this. And the reason why there's this line here is because it treats 360 as 0, obviously. So at 360, it goes back to 0. And so you would see it go like this, but it's the
Yeah.
exact same. And is this to be expected?
As far as I remember, no, but Araceli asked to see again what is the name of the function. I'll tell you now.
Mhm.
NumPy. Right. So I see that you can use either you can use sklearn.
Okay.
So I add it in the chat, the print
Thank you.
screen.
Okay.
And this is just from a simple Google search of
Okay.
in Stack Overflow, right?
Okay.
So you can just see that you have also in NumPy the norm, and probably also in sklearn you have the normalize. Great.
Okay, so the reason why the plot doesn't look like it's supposed to be is because I'm supposed to normalize the population vector.
I think you also, it looks like you didn't use the rectification.
Okay. Okay. Um,
Right, because there
okay.
is a rectify in the sine, and the cosine could not be smaller than 0.
But okay. Yeah.
So you kind of need to do either an absolute or, yes, just an absolute. So I
but
think this is the problem.
okay. But I think I am okay. I'll just so the plot isn't supposed to look like this though. It's supposed to
No,
be okay.
there
But
should be a range where the population vector, the conium, is not good.
But I think that with sine and cosine, it gives you 0 or 1. So
yeah, that's why. Hmm.
So I have my solution for this. And in my solution, but it should be only cosine, Iran.
Yes, of course. Look, you always take just the cosine of the.
Right.
Wait, you always take just the cosine right here when you do wind direction minus preferred
Yes.
direction. Of course, but then when you do the population vector, when you want to take the preferred direction and turn that from a direction into a vector, you take its cosine and its sine, and you right? That's
Yeah.
what I'm
Okay,
doing.
now I got it. Yes. Yes, I think so, yes.
And then I
Shouldn't
just do
have a problem.
arctan. Yes, I do arctan of the directions, and then I get the guess, and the guess
So
is
no.
correct. For example,
So
mhm.
here is the problem.
Yeah.
So I think this is it. You don't use the. Where do you use the firing rate vector? Here, okay,
Here,
right? And
I
show me
multiply.
again the vector of the firing rate. How you
So the way I found the
calculate
firing
it.
rate is by
Yes.
doing baseline plus the highest of 0 and the cosine between wind direction and preferred direction.
I don't know, but it shouldn't look like this. I don't see where is the problem, but it looks like something. It shouldn't look like a straight line.
Okay.
But
It's not.
for calculating the population vector, can we also just use like NP dot and then firing rate and the vector
Yes.
defined?
Yes.
Oh, yeah, okay.
Yes.
Okay.
Oh, Irene, maybe you used I see that you have this for loop. So maybe you decoded only for each neuron instead of all the neurons together.
But then I append the firing rate. Ah, yes, wait. Because here, no, I do it in the loop. For each firing, okay, I'll check this. Thank you. I'll check whether I'm doing it for the.
If you use all the neurons or only one of them.
Okay.
But if
Thank
it's
you.
on the neurons, if it's on the neurons, it's only summing the results of each one, right?
Excuse me, Araceli?
I'm sorry. If it's all the neurons, it's
Yes.
only summing all of the results for each neuron.
All of the results, yes.
Okay.
But when you decode, when you want to decode what is the prediction, then you need all the neurons and not only one of them. And I think that it might be that this is the mistake here.
Okay. Okay. And then quickly, the other thing was about question 2, where, sorry, I need to find where I have it. No, not this. I'm sorry.
Yeah. Okay.
Okay, I can just, no, here we go. Okay. So when we have to check the very first question where it says that there could be different syllables, but the perceived syllables is always B, always. So when you look at the file, your second column is always going to be B. The participant will always hear B despite the whatever presented. Am I confused that to me that means the likelihood is always 1, always, because no matter the prior, you're always going to hear 1. Always going to hear B. So B has likelihood 1, always. And then that trickles through the rest of the exercise. When we have to use likelihoods again, it's going to always be 1. But am I misunderstanding something? Because this makes the rest very simple. So
no, it's only no, it's a conditional probability, so it's not 1.
but if the likelihood is the multiplication between the probability, like the likelihood of observing B is always 1, no matter what was heard, no matter the prior, it's
But
always 1.
Where do you see that he?
Let me see where so when you look at this, see the second column, the column of is all B's. On the right is the perceived, and this is what the pronounced. So if the participant always hears B, no matter what, the likelihood of B is always 1.
No, but it should be a conditional probability.
Maybe I can
So
share
this is the
screen.
difference in what you see. It is to hear B given that the actual sound was Ni. To hear B given that the actual sound was D. Or do you mean that?
Can I share my screen? Because I the way I reasoned the exercise was exactly like Irene says. But then I did something different.
But in the wait a minute, in the CSV, do you have other perceived?
No, it's
No,
only one.
just B.
Only B.
Just B. Always B.
And that's what I thought, that when we need to calculate the condition probability, that we also need the other perceived.
Yeah.
Yeah.
Because of course it's conditional on the priors, but no matter the prior, you're always going to have 100% B.
So the way I thought it, do you know if we can draw here?
Yeah, but we don't see your screen, Araceli.
Okay.
So you know what? Just let me double check it with there. I understand what you mean, that it's always one, because you don't know what are the other possibilities.
Yeah.
So you cannot divide it by. What about the probability? What about using base rule?
But even if you use Bayes, right? When you want to have your posterior and you're calculating Bayes, then the likelihood that you're multiplying the priors by, the likelihood is still 1, right? No,
Yeah, I think it might be that this is just about the idea that we wanted to make it easier for you. So we gave it as this one, and then you need to divide it by the occurrences. I think this was just the idea that you need to divide it by right, P of theta, exactly.
So this is how I thought about it.
Yeah.
We want the probability of perceiving the syllable B given the actual sound, which is S.
Exactly. Yeah.
And since we don't have it because it will always be 1, we can think of perceiving B as theta.
Right.
So we have the probability of the actual sound given perceiving B, which is the number of actual sounds divided by the total,
Yes.
multiplied by the probability of perceiving B.
Yeah.
And perceiving B is the probability of, so there is 256 rows, which all of them are perceiving B.
Exactly.
But in total, we have 1,200 syllables, trials. So the probability of perceiving B is 256 divided by 1,200. That's how I thought about it.
Yes.
But then you would get something like this. For each one of the syllables.
Right.
You would get a value. So I was wondering, what kind of function is expected from us, because I get something like this. So I don't know what's the.
But I saw that you asked me about the function, but I don't remember that you're asked about the function. You're just
you're asked to plot the
each
function.
time you need just to. Oh. So when we say the likelihood function is just about what you just showed. This is what we mean, like a histogram of the different probabilities.
Okay.
Right?
And so
now this is the likelihood because this is before you multiply by the priors. So it's
And-
like you have the posterior and then you need to calculate the likelihood and the prior. So this is just about the idea, yes.
So really, we want the likelihood of the presented syllable given that B is heard, not the likelihood of B being heard given the presented syllable. We want the opposite of what I understood.
Exactly, yes, yes. We
Okay.
want the likelihood of all possible sounds, yes. This is the likelihood, right?
Likelihood of the presented sounds. Okay.
Yes.
Okay.
Sorry, so if this is fine,
Yeah.
so this would be the answer for A.
Yeah, and I probably just add the numbers of each one, either by text or on the bars themselves, yes.
Okay, and I didn't get quite well how we are supposed to get B.
Right, so now that you have all the probabilities, you can calculate the MLE. What is the most likely one? What is the most common sound that was presented?
Because from the graph, I would just take B.
Exactly, this is what you need to take. So probably
Isn't it obvious? Because it's always B, so isn't it obvious that this one would be the MLE?
So you're asking whether, okay, if most of the time this was the true sound that was heard, I mean like the true sound that was presented, sorry. So yeah, this is the most likely, but I need to double check it.
Okay.
As far as I remember, it wasn't B, but I'll wait a minute. I check now while we're talking. So I'll just double check it, but yes, the idea behind the MLE is that this is the most likelihood sound. Yes.
Okay, thank you.
Right.
Okay, so thank you so much. I had really similar questions. There's just one more question I had for task 1. I think already someone asked it in the group, but I don't remember the answer. When we had to calculate the standard, like the SEM for task 1E, do we need, because you wrote that we need to plot it also, but you cannot really see it because it's so small.
I really just didn't hear you too good. Can you repeat the question?
For 1E, we needed to calculate the SEM and also like plot it. But I cannot, like, it's not really visible because the SEM is so small. So is it fine that it's just like you can just see it when you really zoom in, but it's
So maybe try to, we don't need to zoom in into things, but you can just zoom in into some parts. I mean, like taking the plot and then presenting it fully and zooming in on other parts that you want to emphasize. Okay.
okay. Yeah, thank you.
You're welcome. Okay, and I just double checked about the B. I think there might be a problem with how the question is written, but yes, it is B the most likelihood.
Okay. Thank you so much.
You're welcome.
Can I ask something about the first question?
Yes.
So Yeah, for the I'm still super confused how we should do this, but the way I normalize first, as Irene was showing, I divided by the length of each vector. So this is like the first normalization step. After I get array, I divide by the length.
This is the normalization. This is not a normalization, Araceli, because when you use len, that means the number of indices in your vector. And here what you want is it's like a Pythagoras. That you need to have a square root of all the squared values in this array. So the right thing to do is not divide by len, but either divide by norm.
Sorry, I didn't hear the last part. Divide by what?
Norm.
The one you showed us.
Yes, the one that I just attached to the chat.
Okay, I'll check. And then,
Araceli, are you sick?
yeah, super sick. I'm sorry.
Okay. Wow. Do you want us to talk on a different day? We can
No.
schedule something in person when you feel better.
No, it's fine. It's fine. So here, after I normalize for each neuron, I subtract the baseline rate, divide
Yes.
by the maximum rate, and this is what I multiply with VI to get the population vector. So I get a vector for X coordinates and then for Y coordinates. And this is what I get for the four interneurons.
So this one looks better. But I think there is still a problem here. It shouldn't look entirely like this. Something around 90 and 270 is kind of flipped. So you need to double check what happened over there. But it looks better than, yes, something is flipped over there.
So 90 here and 270 here, right?
Yeah.
It's axis.
Yeah.
Okay.
Maybe you need to see if you rectified or used absolute, something over there.
Okay.
Is wrong.
I didn't understand quite well. What is rectifying? Sorry.
So rectifying means that if you have a number smaller than 0, you assign 0 to this number. Maybe you used absolute instead of
Okay, I'll check that.
Okay.
And then yeah, because I had the problem of the same graph for the 8 interneurons.
Yeah, it should look different, yes.
Okay. And for the Gaussian, I think it should also look different, but I get the same result.
No, but you see that it's a bit more noisy. So the noise is added probably in the right way, but again, the problem is something there with the rectification.
Okay, I'll try it. And here I didn't understand correctly, maybe because I thought RMSE was just one value per graph.
Yeah.
But from what Nile has just said, now I think it's something that we have to plot, maybe. Or maybe I understood wrong, sorry.
For me, it's also
so it's just
since you simulate it 100 times and each one you had a different noise, then for each one of the trials you should have a bit different RMSE, right? So this is what Neil just said. If you have 100 trials, did you average across the different trials? So this is why you have only one RMSE. You need to calculate the RMSE for each one of the trials.
Okay, and then plot.
Yeah,
Okay.
plot or just, I would probably present it with a histogram and not even a plot.
Okay.
Just the different RMSEs for each trial.
Okay. Okay, then I'll have to check the rectification.
Yeah,
Thank
something, yeah, in the basics, and check again the normalization of the vector that we just talked about, that it was len instead of norm. Okay, feel good, Araceli.
Thank you so much.
Thank you so much.
You're welcome. Is that it?
For now, yes.
Okay, great. So see you today, later.
Yeah, thank you.
Bye-bye.
Later. Bye.
Thank you. Bye.